Significance testing and measurement comparisons uses statistical tests to decide whether the difference between two measurements is larger than what we would expect from their reported uncertainties, commonly using a t-test or z-test to compare the observed difference to expected variation. Think of two people timing the same race with different stopwatches that each have some wiggle room in their readings. Significance testing asks whether the difference in their times is just from that normal wiggle or from a real problem like a broken stopwatch. You first calculate the difference between the two measurements and then use the reported uncertainties to find how big that difference should be if only random error were present. A z-test is used when uncertainties are well known and the sample size is effectively large or the distribution is normal, while a t-test is used when the uncertainty comes from a small sample estimate and you need to account for extra uncertainty in that estimate. The test gives you a number that tells you how many times larger the observed difference is than the expected variation, and you compare that to a threshold to decide whether the difference is significant. A common mistake is treating every difference as significant just because it looks large, when you must compare it to the combined uncertainty. To avoid this, compute the test statistic rather than relying on intuition. Another mistake is using a z-test when the uncertainty is estimated from a small sample, which can understate uncertainty. Use a t-test in that situation. A third mistake is forgetting to combine uncertainties correctly from both measurements, so make sure to add variances, not standard uncertainties, when finding the expected variation. For more videos and resources on significance testing and measurement comparison, visit www.gumballdegree.com.